The U.S. Air Force in early 2020 expects to formally request proposals from industry for replacing the engines on the Flying Branch's 76 B-52 bombers. The request for proposals could lead to a multi-billion-dollar program to swap out the 1960s vintage B-52's 8 Pratt Whitney TF-33 engines with more efficient modern motors that could reduce the bomber's per-hour flying cost and extend its range and payload. On the eve of the RFP, the Air Force has released concept art depicting previous proposals for re-engining the B-52. The older proposals date back to the 1950s and serve as a reminder that, for nearly the entirety of its long service life, the B-52 has been a candidate for new motors. The first production B-52A first flew on August 5, 1954, with the first in-service B-52BS following a short time later, the Air Force noted in its retrospective. Despite being powered by a Pratt & Whitney J57 engines, the bomber felt underpowered from the start. Even with water injection added for additional thrust at takeoff, the aircraft suffered from marginal performance with a full weapons load on a hot day. In early 1956, Major General L. Boyd, the Deputy Commander of Systems, Air Research, and Development Command, asked industry to consider replacing a pair of J-57s on each wing with a single afterburning J-75 engine in order to boost performance. The prototype XB-52 was made available and the aircraft made a series of flights in this configuration between November 1957 and August 1958, logging over 140 flight hours, the Air Force noted. Despite the final report stating a substantial performance improvement, the configuration was not adopted for the fleet. The last B-52s, H models, left the Boeing factory in October 1962. The H models are the only B-52s still in service. They flew with TF-33s in place of the original J-57s. The Air Force still wasn't happy. Another attempt to find new engines came in 1969 when Boeing began a study to re-engine the B-52 fleet, and again in August 1971 when the Air Force and Boeing performed a more detailed study on replacing the engines with high bypass ratio turbofan engines on all B-52G and H models, the service explained. Boeing studied a concept using a single turbofan on each of the 4 wing pylons and another that used 2 engines on a single inboard pylon. During 1975, with the highly contested Rockwell B-1 program in full swing, members of Congress offered a re-engined and upgraded B-52I as a replacement. Again, it was not adopted. In the 1980s, Pratt & Whitney proposed replacing the B-52's ATF-33s with 4 PW2000 engines. At the time, the Air Force expected new B-1s and B-2s fully to replace the B-52 fleet, so re-engining appeared to be a waste of money. But a new engine again became a viable option following an incident in 1996 during which a B-52 suffered a double engine failure, causing engines numbers 3 and 4 to fall off the bomber. In this case, Boeing and Rolls-Royce teamed up and proposed the use of the Rolls-Royce RB211-535, similar to those used on the commercial 757 aircraft, the Air Force recalled. The Air Force once again rejected the proposal. The rising cost of maintaining the aging TF-33s finally forced the issue. By 2003, the cost of overhauling the old TF-33 engines had tripled, the Air Force noted. In the 2010s, the 60-strong B-1 force experienced declining readiness rates owing to hard use over Afghanistan and Iraq. The B-2 fleet meanwhile shrank to just 20 airframes following a 2008 crash on Guam. The Air Force in 2018 decided to retire the B-1s and B-2s in the 2030s and build its long-term bomber fleet around new B-21 stealth bombers and upgraded B-52s. Re-engining finally gained traction. The goal is 20 to 30% better fuel efficiency with a 40% increase in range, ease of maintenance utilizing the latest onboard diagnostic equipment, and lower greenhouse gas emissions, the Air Force stated. Pratt Whitney, Rolls-Royce, and General Electric all plan to submit proposals. Combined with a wide range of other B-52 upgrades and life extension efforts, the multi-year contract for more than 600 replacement engines could cost around $32 billion.